Hello there, welcome back to My GCSE Chemistry and this last video in the chemical analysis topic. In the previous two videos we looked at ways in which we can identify both metal and non-metal ions by doing various test tube tests and flame tests. But it's worth knowing that in the chemical industry there are machines and particular instruments that are used to detect and identify a variety of different elements and compounds. For the exam, the main thing you need to do is to be able to state the advantages and disadvantages of using instrumental methods compared to the chemical tests that you learnt in the previous two videos. The main advantages of these instrumental methods of analysis are that they're more accurate, more sensitive, quicker, and often able to test much smaller samples so that you can identify even trace elements in a sample. However, some of their disadvantages are that they're normally very expensive, and they're complex, requiring special training. And rather than just observing a colour, it's normal that in these instrumental methods you need to compare your result against some known data, which you may not have. Flame emission spectroscopy is the main example of an instrumental method that you may need to discuss in the exam, and it's used to analyse metal ions in solutions. In effect, it's really a specialised flame test, because it starts in the same way. The sample you're testing is put into a flame, and this time, rather than just looking at the light that's given out, the light is passed through a spectroscope. This allows us to analyse and identify metal ions from flame tests even if they don't produce a characteristic colour. The spectroscope produces an output that's called a line spectrum that looks something like this. And each metal ion has its own characteristic line spectrum that can be compared against reference data to identify the unknown ion in your sample. As well as being able to identify specific metal ions, this method also allows us to measure the concentration of the metal ion present in your sample. For the exam, you're not expected to know the detail of how this machine works, nor are you expected to explain why different flames produce different colours or have their own characteristic line spectrum. But you may be given some results from a flame emission spectroscope and be expected to identify metal ions based on what you see. Here's an example of the kind of thing you might come across. Here we have three references, A, B and C. Each will come from a different metal ion, for example A, sodium, B, nickel, C, copper. And then you're given the line spectrum for an unknown sample. And by comparing it against A, B and C, you should be able to identify which of the ions are present in the unknown sample. If we compare A to the unknown sample first, you can see that all the lines present in A are also present in the unknown sample. However, the unknown sample has more lines than just the lines found in A. This means that it's likely to be a mixture of two ions. The sample doesn't contain any of the lines from B, but again when you compare C against the sample, all the lines in C are also present in the unknown sample, and this tells us that the sample contains a mixture of A and C, in this example sodium and copper. And this is how you'd use some results from a flame emission spectroscope to identify unknown compounds. As we've said before, these methods are much more sensitive than the flame tests and test tube reactions we looked at in the previous two videos. So these sorts of methods are particularly useful for identifying trace compounds found in very small quantities, and can be used for identifying trace levels of poisons or toxins, or measuring the purity or mineral content of water. And that's it for this video and this topic on chemical analysis. If you have any questions, feel free to contact us on the links below. But for now, thanks very much for watching and see you again soon on another video by My GCSE Science.